So what we are looking at right here is an NCODE session. And NCODE is a new feature in Opusmodus, which allows you to work with all of the Opusmodus musical functions, create a complete score without having to write any code, because it's all in this graphical interface. So let's put that to the test. We see an existing session right here, but let's go to File, and we go to New, NCODE session, Option Command M. We are prompted for a name. I will give it 8 bars name. This exists, so I'll just replace it. And we get a new file right here. So the way this works is we can start by typing a function, such as setF, the function we use to assign variables. We can then give that a variable. Let's call this chords, and then we can input the values. Now we could input it right here, so we could say a chord, for example, C3, E3, whatever, or we can click on edit right here, and this allows us, gives us a little bit more space, and we can now paste the chords right in here. We can then click apply, and then it gets inputted into this field. You can see all of them are in there. Now if we hit apply again, it will add it to what is called the history window, which is, this is basically your score that you see at the top. So we have that. Then we want to have a new function. This time I want to use MC list, which is a Lisp primitive, and this allows us to put each of the chords in the list that we created here into a separate list. So all we have to do here is type chords, and we can give it a variable again, chords 2, for example. Now if we want to test what this does, we can hit evaluate, and then we can see that it indeed puts all of the chords in a separate list. Then we can hit apply, and it gets added here. Now for the score, I want to use some noise to create a melody. So we can use a gen noise, and you can see that it auto-completes quite quickly for some of the functions. And this takes a bunch of values. Now, we might have forgotten what those values are. So what we can always do here is click doc, and this will take us to the documentation. It will immediately take you to the right page, and we can see what these arguments and values actually mean. So we can see scale, type, and the familiar seed there. So for the count, I'm going to choose 32 distinct values. Scale I can leave there, normal, I can leave all of this. Now I can hit apply. Now if you do this, you might have noticed that I forgot to set the variable name, but it gets filled automatically right here. We can see FLT noise 3. So it's actually a fairly clever automatically generated variable name, and this can be very useful if you really want to work fast. In my case, however, I want to set it to a simpler variable called noise. So now if I apply this again, we see that it gets added below here because it's a new variable. Now what I can do is I can go to variables right here, and I can select it and then move it up to move it just below chords 2. And I can take the other one that was still there that I don't need, and I can click remove. That's one way of doing it. You can also right click here, edit, and then cut to remove a function. Now that we're here, we see a couple of other functions. We can see snippets, which is interesting. We can listen to just this specific variable. We can also graph. So in this case, we're working with numbers. So I can graph the numbers, and then we see all the different points there in a nice plot. So there's a couple of options there. We've graphed for lengths, we have it for pitches. For example, we can go to chords here, and we can graph the pitches, etc. Now you could also see here export to editor. I want to make a separate video on this, but this is a very interesting feature. We can immediately send this to something like MuseScore or Sibelius or Dorico, and we can get our notes into our favorite editor. But for now, let's move on. What I now want to do is I have these floating point values, as we can see right here, but I want to convert those to pitches. So for that, we can use the often used vector to pitch. And this takes a range because it wants to know in between which range you want those pitches. So I'll say, yeah, let's just give it an octave for now. The value would be the values of noise. Quantize we can leave the same, and we can call this sequence 1. Again, we can evaluate this. We don't have to do that. We can also immediately hit apply there. Now that's for the pitches itself. We could actually now go to a snippet, and we can do notation. So these are the noise values now mapped to pitches. What I want to do, however, is I want to create a list of lengths. So we're going to create a new function and we go with our setf again. And when we choose a function such as setf, and there's a couple of other ones, we see a template appear here. And this allows us to create a certain structure for our data. So if we click on this, we can see chord dictum, counterpoint dictum, or list of lists. That is what we want, because I want to create a list of different bars of lengths. So if I choose list of lists here, we can see 1 there is the value. Now I can put in the values that I want, for example this, and then I can choose next and I can go to the second nested list. So here I can put in like 4 quarter notes. I can press next again. I can paste in that same list that I had before. I can do next again. I will go again with 4 quarter notes to get some sort of call and response there. And then let's do something like this. I have to be careful, there's a space in between there. We go to the 6th list. So let's do something like this. I'm trying to make sure that each of them is exactly in 4/4, the total length, but we'll be able to check on that in a second. Let's do quarter note, half note, and then for our last bar, let's simply choose a whole note. All right, so we have all of this. Let's hit apply. Now we can see that it is there. Let's also evaluate, and we see that we indeed get a list with lists inside of it. So that's very nice. One thing I didn't want is this automatic variable. So I'm gonna override that, hit apply, and then I will remove the other one. So now we have a list of lists. We can evaluate it. We could also go into here and click edit. We can see only the last value in this case. So we have our lengths. Now let's use a make OMN function to actually combine all of that together, because we have our pitches right now and we have our lengths. So make OMN, I'm going to call it sequence 2. And for the lengths, I'm going to input my len list. And for the pitches, I'm going to input my seq1, which were the pitches converted from noise. Velocity, we could do something there. Let's do MP to forte. Let's leave all of the rest empty for now. And then we create that. And now we have an actual OMN event. So let's evaluate that. We can see that looks like a beautiful line of music. So let's listen to that. Not bad, right? For something that's just noise converted without any harmonic path or anything like this, without anything to map it to a certain scale. Still sounds pretty good. But let's do that next. So what we want is we want to use tonality map. But before we use tonality map, it's nice to have a tonality series. We want to know which tonality we want to work in. So let's go with new here. And for the function, we're going to choose tonality series. It's right there. This one is another one where you might want to see the doc on. It's an excellent documentation on this function, as well as the tonality map. So for the name here, let's choose just T-series to keep it kind of obvious what's going on. And then for the scale, what we want here is we want our list of chords. And these chords have to be in sublists so that it can map better. So we're going to choose chords 2 here for the scale. And then what other parameters do we have? The map one is interesting. Let's go with extend there. There's different map options, which is how it will map the notes to the chords. I've done a couple of videos on this. And the embedis we can leave at piano, which is basically a very wide range. So let's apply that. And then let's create a new function, which will actually be the tonality map. So let's choose that, and the tonality map as an input gets the tonality series. So here scale, the first argument would be T series, and the sequence would be the sequence that we're working with. So that was sequence 2, and we can give it a name. And let's call this, since we're going to work with, I'll work with the piano staff, so I'll call this right hand, because this is going to be the melody, right? So in the right hand of the piano, that works, and we can apply it. Now all I want to do is add a left hand to this as well, and I'm going to keep it very simple. So I'm just going to go with the make OMN function, OMN. And then for the name, we'll call this left hand. The lengths will just be whole notes, and the pitch will be the original chords that we provided. We also have to make sure the span by default is set to length, which means that the length list will define the total length. So in this case, we would only hear one chord because we have only one length. So I'm going to set this equal to pitch, so that we hear, actually, I'll show you both. So if I set this to length and I evaluate this, you can see we get one chord. If I set this to pitch, the length is going to be the same as the amount, of course, that we have. So we get 8 bars in this case. So with that, we can hit apply. Now, a couple of things that we haven't looked at, is one of them here is the repeat parameter. If I create a new, let's say, a new set F, and I can say value 1, name test, and I choose 4 here and then apply, we can see that we get 4 set Fs here after each other. Just to show you that, I don't want this, so I will remove these. All right. The code we talked about, we have the clear editor, which just clears the window here, and we have clear all. That's the one that we don't want to hit generally, or at least it's good to hit Command S before that if you want to save something. Also, what we have above here are the filters. So right now, since we have a bunch of different types here, we can filter for only the numbers, or only the lengths, or the OMN events, anything that we edited since we saved it. I just saved it, so we don't see anything there. So that's what this list is for. Then we have the save to file, which is very nice because this will prompt you for a pad. Let's say, what did we call this? 8 bars.opmo, and you can see that it puts it in the NCODE folder, in the media folder. So we can go there now, and then we can see what this looks like when we have it in code. So this is what you normally would have written, instead of just simply filling out these parameters here. So this is very nice if you want to continue in code, or you just want to back it up in sort of a raw code kind of format. You can always do that by hitting save to file right here. For us though, one thing that you might notice is missing is the define score, and that's the last big thing to talk about. So we have this button here, define score, and this takes us to the def score page. And here we can set up some parameters to actually be able to play this back. So the score name is already filled out here. It's called 8 bars. There's a couple of required values, such as a key signature. We can, for the time signature, simply choose 4/4. For the tempo, let's choose 120. And this we can, all of this we can leave empty. Now for the layout, we want to choose a, I said we're gonna do piano, so let's stay true to my word. Piano, piano, piano. There, piano layout. And then for the instrument here, we will say, let's do left hand and right hand. These are going to be the instrument names, and then this name right here. Now we simply add this to the layout. So then it will show up here. And now we need to add staffs for that. So here what we can do is we can call this one left hand, for example, and we can see the variables here that we created, the valid variables that are actually playable. So we choose left hand there. For my port, I will choose this one as a port I created. Channel can be 1, and these two can be ignored because I'm going to send this to a DAW. So we added one clef, and now I can add a new one. We'll call this one right hand, and we choose the right hand variable there, the same port, but this time I will send this to channel 2. And then we can add that. So now we created a def score instance with two different clefs. So let's see if we can actually play this. So I'm going to click on notation. Okay, so that works, but the clef is the other way around. So we have right hand, left hand right here. Let's do that the other way around. So we would have left hand, right hand here. We can add this, and then we need to delete the old one. And let's try that again and see if we have everything in the right clef. All right, so that works. Of course, this is not very exciting. I would do many things with this. I would filter tie some things. I would get some more movement. Right now we only have a melody range of an octave. I would improve all of that. But that is a very basic idea on how to use NCODE to create a short snippet of music without writing code. Now, one thing I should mention is that always before you play, before you do notation or MIDI player or live coding, you want to do a refresh all. That's an important button. The last one I didn't talk about, and this evaluates everything in order. So before you do anything sort of final, press refresh all, so that you know that all of your arguments have been or all of your functions have been evaluated in the right order, and all of your variables are set correctly. So I hope you found that fun. Play around with this. If you have any questions, use our forum, and I hope to see you in another video.